This is the DNA Dispatch from All Access DNA, where we will highlight current news stories in genetics. These stories today show how genetic information can be used and challenges with genetic privacy. We'll cover new Olympic testing rules, life insurance, and the use of genetic data to train AI. This is something new we are trying, so let us know your thoughts and fill out our listener survey. The link will be in the show notes. Our first story of today. Starting with the 2028 Olympic Games in Los Angeles, the IOC is requiring all girls and women competing in the Games to undergo mandatory testing for the SRY gene. If they refuse the test, and subsequently the sharing of private medical information, these athletes will not be allowed to compete in the Olympics. Men are not required to undergo this testing. So, why does this matter? About 1 in 50 people have a natural variation in their sex traits, and many of these folks don't even know it. With the required SRY testing for girls and women, some of them will find out that they have a sex trait variation for the first time with no support or privacy. Also, they will have a test that actually does nothing to determine biological sex and is in fact unreliable and misguided. The SRY gene is located on the Y chromosome, and you may have learned in school that XX are females and XY are males. But that isn't the full story. Biological sex is determined by many genes, as well as multiple hormones, proteins, and additional factors. The SRY gene is on the Y chromosome, so typically, if a human embryo has XY chromosomes and a functional SRY gene, then about 6 weeks of gestation, the SRY starts a chain of events that include 30 plus other genes to form the testes. The testes are the organs that produce hormones, including testosterone, that leads to male development. And even after the testes form, there are other genes and hormones needed to maintain them and their function. Changes in genes or hormones can affect how a testes or ovary develops, which means a person can have a testes or ovary that doesn't work properly. Some people are XY and have a working SRY gene, but they can have internal testes, and their body doesn't actually respond to testosterone produced by these testes. One condition that does this is androgen insensitivity, which is not found by SRY testing alone. While testosterone plays a part in muscle mass and strength, having the SRY gene doesn't mean someone makes and responds to testosterone. The last time the IOC implemented SRY testing, it was the 1990s. At the 1996 Olympic Games in Atlanta, 7 out of 3,387 women athletes had a positive result, meaning they had the SRY gene and a Y chromosome, but were then determined to be resistant to testosterone. For the 2000 Olympic Games, an expert panel presented information to the IOC that convinced them to drop the use of SRY testing for biological sex. Since that time, the IOC has used a comprehensive team of specialists in various areas like endocrinology, genetics, gynecology, psychology, other fields to verify the gender of an athlete when requested by the IOC's medical commission. In short, there's no single gene that defines sex. There's no single hormone that defines sex. And there is no single test that defines sex. The IOC is moving back to the past and using flawed science, unfortunately. I guess the 90s are back everywhere. If you're curious to learn more about this topic, we have 2 other episodes we can direct you to. The links are in the show notes. One is titled, What are Sex Trait Variations and How Do We Support Intersex Individuals with Caitlin Brown. The second is Does Genetics Influence Sex and Gender with Kim Zahowski. Next up, our second story. This one comes to us from Australia. Australia recently passed a law that bans life insurers from using genetic test results to deny or discriminate against applicants. That means that life insurers cannot use predictive genetic data in underwriting, and they cannot ask if someone's relatives have had genetic testing. So for context, the United States, where I live, has no such law. Why should you care about this? Well, when you apply for life insurance, the companies use the underwriting process to assess your risk that you could bring them as an insured person under their policy. That means your costs, exclusions for coverage, or potentially even being rejected for life insurance depend on how risky your health is. Australia recently passed a countrywide law where life insurance companies cannot use genetic results in underwriting. Both Canada and the United Kingdom have similar protections. The United States does not. The United States does have a federal law called GINA, or the Genetic Information Non-Discrimination Act. But GINA only applies to health insurance and employment. It doesn't apply to life insurance, disability insurance, or long-term care insurance. GINA also does not apply to all types of health insurance or employment. For example, military insurance, such as TRICARE, doesn't fall under GINA. Some states have introduced specific bans on using genetic results in determining life insurance coverage, but they may only apply to one specific condition and to not all genetic testing results. In fact, Florida is the only state to pass a law prohibiting life insurance from using genetic results. I looked at some of the states that I've lived in, like Texas, South Carolina, Georgia, and none of these have any protections for people's genetic data being used in life insurance underwriting. There have been reported cases of people being denied life insurance or being charged premiums due to a condition that they don't currently have and may only be at risk for because of genetic results, meaning these people may never actually get the condition that they have a positive genetic test for. One way to be aware of what's going on with your life insurance policy. Make sure you know your state laws on genetic information and life insurance. In our show notes, there is a link to the resource from the University of Iowa on genetic privacy that summarizes current state laws. If you want to learn more about insurance and genetic test results, you can check out one of our episodes called When is Rare Disease Not So Rare with Susanna Smith. Another recommendation is a podcast that I produce called the DNA Dialogues podcast. Check out episode number 27, Protecting Genetic Information, Life Insurance and GINA. Finally, for our last story, recently a genetic testing company called Tempus AI is facing multiple lawsuits alleging unauthorized collection and disclosure of genetic testing results. Tempus AI obtained these genetic test results when the company purchased Ambry Genetics. Tempus then used genetic data from hundreds of thousands of patients to train its AI models. Why does this matter? Well, first off, the legal disclaimer. Please note that these are allegations in a civil complaint and nothing in this lawsuit has been proven in court. Tempus AI may have defenses that have not yet been presented at the time of this recording. The case is important because it brings up a good discussion about how labs could potentially use genetic data for themselves or someone else, and whether or not genetic data can ever really be de-identified or anonymous. As part of Tempus AI's purchase of Ambry, Ambry was required to disclose its large database of genetic data to Tempus. The lawsuit alleges that Tempus failed to obtain customer permission to allow Ambry to disclose their genetic information as required under certain state laws. Tempus has agreements with over 70 companies, including pharmaceutical companies like Pfizer and AstraZeneca, as well as biotechnology firms. The lawsuit alleges that the genetic data derived from the Ambry tests was then provided to those clients under these agreements, and that this resulted in deals totaling over $1.1 billion. Tempus and Ambry state that they both only disclose de-identified data. The question is, can genetic data ever really be de-identified? Your genetic information is permanent and personal. It can predict future health issues that extend to your biological relatives, such as children. And while your name, date of birth, diagnosis, other identifiers specified under HIPAA can be separated from your genetic data, that doesn't fully eliminate the chance for re-identification. A database that is anonymous can still be used with other data sets and public records. Consider some of these now solved cold cases that have been in the news the last few years. Other ways labs attempt to anonymize data is by using it as one big group. So this means that genetic data from many individuals is combined when reported or shared somewhere because no single sample is easily identifiable. However, there are bioinformatics tools that make it possible to re-identify from this aggregated genetic data. Finally, many companies cite HIPAA compliancy, but HIPAA is actually focused on portability. That's what the P in HIPAA stands for, rather than the privacy of medical information. And we know that HIPAA alone is insufficient for protecting genetic privacy. At the time of this recording, we're going to have to wait and see what happens in court and what happens with these allegations. No ruling has occurred again at the time of this recording. When you do genetic testing, you can make sure that you understand the privacy policy of the lab performing the testing and read the fine print. You can also look for options on the lab paperwork that allow you to opt out of sharing or request the destruction of your sample and possibly data. You may also have the option to download and delete your data after getting results, depending on the lab or company doing your test. If you want to learn more about genetic privacy and genetic data, check out our episode on Should I Delete My 23andMe Data with Anya Prince, or our more recent episode, What Should I Know About Buying a DNA Test with Andrew McCarty. That's a wrap on these current news and genetics. Take some time to let us know your thoughts on this new segment and fill out our listener survey. Again, the link is going to be in the show notes. We'll be back next time with an all-new interview. Thanks, DNA. For more information about this episode, visit allaccessdna.podbean.com, where you can also stream all episodes of the show. This link is also in the show notes for easy access. Any inquiries on the podcast can be sent to allaccessdna@gmail.com. Check out our Patreon at patreon.com/allaccessdna and consider donating to get bonus content, submit questions for our guests, and connect with other genetic curious individuals. Note that this podcast is for entertainment and education and is not intended to be a substitute for professional medical advice. Please consult your physician with any questions you may have regarding your health. Please rate and review the podcast on Apple, Spotify, or wherever you listen. This helps other people like you discover the show. All Access DNA is hosted, produced, and edited by Kate Wilson. The logo design is by Designs by NKJ. Thanks for listening and join us next time.